Hello, YouTubers. Yeah, the SDR went down. I think I got a problem right there. So, that'll have to get fixed. But, what I wanted to show you. Alright, y'all wanted to know if the Magloop was transmitting. And boy, did it ever. It doesn't care if that's there at all. But what's cool is I have standing wave adjustment with this. It did work, so I tried it long ago, a couple years back. I couldn't get it to work right. I know what I did wrong. I had a lot of stuff wrong on the inner loops, little loops. But I finally got this one to work, and I'll show you on the radio here. I found out how high Q that is, and it's really high Q. Man, yeah, I hate this now because I used to show you guys on the big screen, and now I only got that little screen. So I left it running. It's on, let me get close. There, move my finger. It's on AM, guys. That way I don't have to talk because I don't have my license to talk up here. So I'm over here on the CW side. Basically, I'm just making sure nobody's transmitting, and I've only got it set to 5 watts there. So that way, being in the room, I'm not shooting very far. But I'll show you what it does on the standing wave meter. Okay, and let me see here. Alright, best way to explain it, guys, because it still receives, okay, the way it always did. We can switch to the little loop, alright, and knock out the noise, okay. Now, everything works the receive-wise the same way, and it's hooked up the same way. It's hooked up into the switch right here. That's where it's hooked up to. This gray one's the big loop, and the black one's the small loop. And I was going to show you guys too later on. I got my dummy load in, so nice place to put your dummy load is pretty close to your ground because you're splattering RF everywhere into that dummy load. Set it next to your ground, and it has some place to go. Don't set it up on your bench next to your stuff. That's bad, guys. Anyway, alright, that'll be another video. There's the Magloop. This is the big one. Here's the small one. Okay, right now we're on the big one because we're going to be showing transmit. We don't want to transmit to the little one. That won't work. Alright, our little one's just for receive, because what that does is that knocks out our noise. Well, let's see what it does, and I'll switch the switch for you over here on the radio so you can see it still does work. There it goes. That took out all the noise. Okay, so the little one still works. Now, what's cool about the little one, when we go to sideband, let's go to sideband and I'll show you. Okay, now we're on lower sideband. See this amp? This is our preamp. I just put nothing but pure modulation back into that. Now watch what happens when I take it away. You're just getting that sliver of you can see the peaks coming through that's all people talking. This scope on this radio is not good, guys. It's usable, but not good. The 7300's got a lot better scope, but this one has HF. 7300 don't. So I found running the little loop, it likes amp 1. if you put it on amp 2, you kind of overmodulate if you're right in there on them. If that peak of that signal right there is right in there on them. But so you can see that it still works. Okay. There's no zooming in on this one, guys, because that screen is awful. It's small. So, but you can see it still works. You can see the modulation band right in the middle. That's the peak of the Magloop. Okay. All right. Now I'll switch it over to the big one, and the noise will come back. That's just residual noise around. Yeah, you can see it on the ends there. All the little specks right there. Now that doesn't. You can see what it does to the signal meter too. You can see that. But that's running amp 1. When I'm on the big loop, we'll shut that down all the way off. That way you get some of your scope back. It's not as noisy. Okay. Now we need to switch back. Okay, guys. Because I don't want to be transmitting. We're going to AM side there. Shouldn't bother nobody. We're not going to be modulating. Like I said, we're at 5 watts. We're up there in CW mode. I'm still tech, so technically I can transmit there. I won't be modulating. So, but I just want to show you guys the standing wave. Okay. Now, I've tuned it already for this frequency because it is an absolute bastard to tune. I'm figuring stuff out as I go, and I'll show you this here on this video. But now I know why they put stepper motors on these, because the stepper motor remembers where you're at. So you can literally go into software, okay? And as you tune that dial up, right, that stepper motor will know where that radio is at, and when it stops, you just hit a button and it'll whoop right to that frequency. And you'd have a lot of time programming it. Believe me, it would take some time to do that for every frequency that this one can do. But if you're just using it, you just want to pop in on your normal band, you can leave it totally where it's at, the capacitor, and go right back to it. It's still fine. But what's cool, what I think is awesome is this little one doesn't. You can transmit all you want on the big one, and that little one just sits there and says, "Oh, hey, how you doing?" But the capacitor works still, and I'll show you. I use that for fine-tuning the standing wave, because with that electric motor, that worm gear motor right there, trying to get that to just minutely adjust is a horrible thing. So now I know why the guys put stepper motors on them. Yeah, but that's a lot of work and a lot of time. So for just wanting to get on and transmit, this one would work. And I'll show you how all you got to do is get this one close enough, and it's got to be within. I was measuring it earlier, and my guess is within 200 kilohertz. That's not very much. That you can adjust the standing wave and get it tuned, basically. So what you do, basically what you do is you get pick your frequency you want, right? Okay. So let's just say we're going to stop here. Okay. Somebody's talking, you just want to stop here. What you have to do is move that big capacitor right there. Okay. You got to move it to that center of right where you're talking at, for that center of that little beam, or that little peak has to be right there on that frequency you're talking on. Okay, now you could be a little bit off this way or that way of it, and you can use that little one to tune in the standing wave. So that's pretty much how it works. So you're moving in big moves with this one, with this capacitor. This is the motor driver controller for that capacitor, the big capacitor right there. Okay, so you move it with that across the band, and it'll go from 30 down all the way down to 80. All right, and just like you guys always seen on the other videos, you know how far it goes. If you watch those other videos, you can just see it roll it right through the SDR screen, how far it goes down the band. Okay, so as long as you're in that peak right there, you'll resonate. You'll drop your standing wave, but you need some way to fine tune it. Okay, and that was the problem that a lot of people have with Magloops is they can get it close, and then it's a real bear to get it tuned exact for the standing wave to work right. Well, that's where this one comes in. And it's like a double whammy, because you get the receive off of it also, and it adjusts your standing wave for the whole thing. Okay, so you're kind of dogging it in there with that, lobbing it in there. And then you reach up there if you test it, and you can adjust your standing wave there. So I'll show you. All right. And let me look at the scope so I can see. No, nobody's transmitting. Okay, good. All right, now we're gonna leave it there. We're on 5 watts. Okay, AM. Okay, we're not on upper or lower sideband or nothing. And I'm just going to drop the key down here, and you'll watch the standing wave. Now this is the big loop. Okay, we're over here off the switch. Make sure we're over here on the big loop. Okay, so let's drop it down with 5 watts and watch the standing wave. Boom. Okay, now let's just not doing anything. We're gonna change nothing. Let's walk over here and let's tune this just a tad. All right, now we were at 1.03 before, right? Okay, so let's just move at that one just a little bit there. Now watch what happens to the standing wave. Well, here, I'll let you watch me key it here. 1.5. Okay. So all we did was nick that to the right a little bit. Now let's go back to the left. Okay. Now you got to remember, guys. All right, we just went to the left, back to the left. So let's see what it is now. Oh, we almost hit it dead on. A 1. I'd say it transmits. That ought to be good. But I want you to remember now. You got to remember that little loop is not hooked up. All right. Right there. Okay. Let me show you. We're over there on the big loop side on the switch. So just so you guys can see this, because I got some comment, or I got a couple of emails saying, "Hey man, you're faking that." No, I'm not. So I'll just unhook it. Okay, we'll just set it. Oops. We'll just set it right there on the floor. Okay. So that little one's not even hooked up now. Okay. Go over here and do it. Switch the switch. Just totally dead. Okay. All right. There you go. Okay. So now we're back on the big one. Now, our standing wave, 1.05, didn't change. See, we're down there right at 1. Okay. Come over here and we'll bump this one. Now it shouldn't work, guys, right? It's not hooked up. Just bumped it again. There's your flux working. That's your flux. That's how it works, guys. It's not even hooked up, but still working. Okay. Now let's draw it back here. You can see. Let me draw it back here. Try to get it back to 1. Oh, got it to 1.5. A little bit more. There we go. Almost a 1. Still unhooked. See? So, it doesn't matter what you put in there, right? Now here's one thing it will affect, I think. And I'll have to get it outdoors, guys, to test this. But I think what it'll do is, because that little loop's in there, you got that other smaller loop in there. I believe that'll change the velocity factor, the velocity thing, how that works. It'll definitely change the lobe, I think, of that. So it'll either be for the good or for the bad. It may even give it a little beam direction. I don't know. A little bit more beam type transmit. I think that's what it's going to do. It works that way on my compact tent up on the roof, and that thing is awesome, guys. But yeah, the 2-meter micro beam, that's the stuff. I need to get it higher. Height is the key with that thing. But yeah, that smaller loop doesn't care. It just sits in there and does its own thing. Eventually, what I'll do is find out where that thing's resonant at. Can you imagine finding out where that thing's resonant and then using that big capacitor? Because it'll see that big capacitor if I find out where that one's resonant at. I think it's close to a little over 2 meter now, because I messed the length up on it, trying to tune it. So I'm going to play around with that and find out, because I really want to make a video of that using the little loop, the big capacitor on that little loop. That might be funny. Yeah, but that we'll have to see. But to be honest, I didn't have to adjust anything here. Matter of fact, watch, I'll show you. Let's just pull this one down. Pull it away a little bit there, right? That's a good little distance there. Now watch what it does over here. It affects it, but not a lot. I mean, that was 1.0 before, and it's just 1.1. So look how far I moved that. Ooh, I got some static off that. Wow. Okay. Yeah, that's a little charged. Oh, I guess I should ground that little bastard. Hang on. Let's set that on the ground. There we go. Okay, yeah, guys, don't transmit and be real close to this. But yeah, it just doesn't see it. So if I could get that big one, that little one to resonate, we'll find out where it resonates. I'll have to, it'll take me a day probably. Then I'll switch to the little one, and then we'll play with the big capacitor on that. That'd be cool. I may just get it working on 2 meter. I may just do that for you guys, because it was close, and I moved it. I cut it too far. You always do that. You always go too far. So, but anyway, you can move that all you want. You can move it more. It doesn't really. It'll start raising this anyway. I got it down and way down there before. Yeah, it just keeps going up. 1.3 now. So I just been running it up here all the way. Okay. And so that it hasn't moved. I thought I'd have to adjust that a lot more than what I'm doing. I'll put it to you that way. So I wouldn't work as hard as putting an adjuster thing on yours if you're going to build one. Just stick it close and glue it, stick it up there. I worked hard on getting that to slide and everything, thinking I'd have to really adjust that, but to be honest, it likes it close. That distance right there is really good. You can see what that is. That's my finger, so that's less than a half an inch, or maybe half inch. So, but yeah, I guess I won't have to do it. I haven't tested it with the little one yet. So, but it doesn't care that it's there. It might change the velocity factor transmitting. So that's the only other concern I have now. So what I'm going to do now is weatherproof it. Final build it. I'm going to put a cap on the top to lock those two together up there. And then I'm going to paint it. And then get the boxes for the weatherproofing. So it'll be weatherproofed. And then work on a steel clamp to clamp the whole thing in. So that'll be my next little adventure with it, because it does transmit. It's awesome, I guess. You know, if you set the standing wave on it and it works on one band, it'll be the same on the others, guys. You won't have no problems there. So if it works on FM, it'll work on sideband. So you shouldn't have much adjustment. Even if it did jump, you can take it out with the little one. So I'm gonna have to figure a way to tune that. So I'm probably gonna I don't know. Man, I hate to introduce another motor. I'll have to think about that. Because it's hand adjust right now, so to fine tune it, you can get it close with this one, but to fine tune it, you need that smaller adjustment there. Now I could have just run that with that, okay, just put it in parallel, okay, and that would have worked. I still could have tuned with it and everything, but you take out that noise thing on your receive. If you take that away, then you lose that bump you get when you switch to it on your receive. And you can see how much noise that takes out. Let me switch it back. Oh, I unhooked it. There we go. Let me put it back. So yeah, I got my connections, guys, all set up for you. I got the dummy load in, okay, and I'm gonna run another video on those and having connections for your radios, because this is gonna have a really weird connection setup, because we're gonna be running the leads from the radios through this, okay, and going out into a 4 switch, okay. And that's a little technical. You know, some of you guys may be a little more technical advanced for you than that. So I was going to do a video on it, showing how you can hook things up differently. Okay. So as of now, everything goes through the meter. Okay. Everything, any connection out of that radio goes to that meter. That way I can see everything. And then from there you go out. And I finally got my DX Engineering cable there. Super high low loss, military grade. $77, guys, for that cable. And I got 3 of them. I need a 4th one too. But yeah, so the little loop's hooked back up. So let's switch it back over. Drop our noise out, as you can see. So it's back in online, but like I said, it doesn't matter. It doesn't see it. It won't affect the transmit. The 1.1. So yeah, that's it works. That's proof of it right there. Proof of concept, I guess. So you can see how the minute adjustment of that, and you can just draw it down to 1 to nothing basically, and but just by tuning that one. So I I might get a really super slow motor for that. That's what I'm thinking. But that'll have to be in a box too. A lot of boxes, that's for sure. It's gonna be getting pretty big. So the next step is trying to get it outside, or get it weatherproof to get it outside. And I guess I may have to go get my general license so that I can transmit with it. We gotta see how much power I can put into it before it flashes. If I do it upright, I think I can get 75 out of it. Might be pushing it, I don't know. But it might hit that motor. It's at 75. But it does work, guys. You can see it, proof. There you go. Now, if you move that big capacitor, and it's, kind of big, so if you move that capacitor any, you've really got to fine tune. It takes a lot of fine tuning. I'll put it to you that way, guys. If you're going to be swapping the bands, going through the bands a lot, this is probably not your antenna. If you're going to be sticking to a little square part of the, like say the general, if you get a general license, you can talk, but it's on a really thin margin of bandwidth there. You park that on that bandwidth right there for a tech, and you can probably fine tune with that one just fine. So, I just wanted you guys to see this because it does work. That's proof of concept right there. The only thing that I got to test is see if it affects the transmit, and that'll be pulling that one off, all right, and then transmit and putting it back on and seeing if there's any difference there. And to be honest, you're gonna have to find people to talk to for that. So that'll be another video. But anyway, guys, I'm gonna mark this one as the next Magloop series. So make sure you hit subscribe and the like. You got to do the like thingy. My videos have been dropping off, but I don't know if it's because people's going back to work. So anyway, I just wanted y'all to see that it does have a good standing wave, and it is a really high Q antenna. So anyway, just letting you know. Anyway, I'm going to do another video again when I get it all weatherproofed. So 73s to y'all, and make sure you subscribe and like. Alright, you guys take care. We'll see you.